But in May 2026, the James Webb Space Telescope looked 13 billion light-years into the past and found something that shouldn't exist. It identified a supermassive black hole in the infant universe that is so large, it challenges our entire understanding of how galaxies are born. But in the same month that we reached this new depth of observation, a much closer mission ended in disaster. At a launch site in Florida, a heavy-lift rocket intended to carry our next generation of lunar and orbital infrastructure was totally destroyed in a massive explosion. The failure had an immediate impact on two major projects: NASA's plan to build a permanent human outpost on the moon, and Amazon Leo's multi-billion-dollar attempt to deploy a global satellite internet network. Amazon, in particular, is now facing a legal crisis. Their FCC license carries a strict mandate. They must have over 1,600 satellites operational in orbit by July 2026, or risk losing their authorization to operate. The contrast is stark. We are capable of observing the dawn of time with near-perfect clarity, yet we are still physically bottlenecked by a launch infrastructure where a single malfunction can ground an entire industry. The rocket sitting on Launch Complex 36 was Blue Origin's New Glenn, a 98-meter-tall heavy-lift vehicle designed to be the primary workhorse for these ambitious missions. On the night of May 28th, engineers prepared for a hot fire test. This is a routine procedure where the rocket is fully fueled with liquid methane and oxygen, but instead of taking off, it is held firmly to the pad while the engines are briefly ignited. As the ignition sequence began for the 7BE-4 engines, a failure at the base of the first stage triggered a detonation. The resulting explosion created a fireball that could be felt for miles across the Space Coast. The blast was total. It didn't just destroy the rocket, it toppled a lightning tower and vaporized the erector gantry used to move the vehicle into place. This wasn't just the loss of a single vehicle. With its only operational pad destroyed, Blue Origin's entire launch schedule for the year was effectively wiped out, leaving its partners without a ride to space. The fallout reached NASA immediately. The agency had planned to use this vehicle for Moon Base 1, a mission scheduled for this autumn to deliver science payloads and rovers to the lunar South Pole. Those payloads are now grounded indefinitely. For Amazon Leo, the explosion is an existential threat. To keep their license for a 3,236 satellite constellation, the FCC requires them to have exactly half of that fleet in orbit by July 30, 2026. The data shows the scale of the problem. Amazon currently has roughly 230 production satellites in orbit. To meet the deadline, they need 1,618. They are short by more than 1,300 satellites with only months left on the calendar. Amazon has already petitioned the FCC for a 2-year extension and is attempting to buy launch capacity from competitors like SpaceX, but there simply aren't enough heavy-lift rockets available to close a gap of this size. It reveals a systemic weakness in modern spaceflight. When launch pads are scarce and rockets are complex, a single point of failure can derail trillions of dollars in commercial and scientific investment. While we struggle with the logistics of low Earth orbit, our spectroscopic tools are performing with unprecedented precision. In that same month of May, the James Webb Space Telescope achieved a landmark measurement. Astronomers targeted a little red dot galaxy called QS01, located 13 billion light-years away. They weren't just taking a picture. They were mapping the movement of primeval gas within a system that existed just 700 million years after the Big Bang. By tracking the rotation of hydrogen gas, researchers detected a perfect Keplerian motion, the same physics that governs planets orbiting a sun. This allowed them to directly weigh the object at the center. They found a supermassive black hole with 50 million times the mass of our sun, accounting for a staggering 66. We've developed the precision to see into the first billion years of cosmic history, but our physical path into orbit is still held back by a fragile launch pipeline. Until we can move beyond these single points of failure in our heavy-lift infrastructure, our most ambitious plans for lunar bases and satellite constellations will remain grounded by the very gravity we are trying to escape. Is the current strategy of relying on a few massive private rockets the right path for NASA, or do we need a more resilient way to reach the stars? Let us know your thoughts in the comments.